Solve quadratic trinomials by factoring using the box method, a harder problem. Recently, one of my valued viewers, Viva La Maria, made a comment to one of my videos, Solving Quadratic Equations by Factoring Part 1. He gave the details of a more advanced problem than any of the examples in my video he had just seen. I could have directed him to my follow-up video, Solving Quadratic Equations by Factoring Part 2, which shows the working of examples of greater difficulty than Part 1. Still, the problem he gave me was even a degree of difficulty higher than the problems in this Part 2. This is the problem he gave me. Solve the quadratic equation 18x squared plus 9x minus 35 equals 0. I worked out the problem. I was able to show to work this one out pretty quickly using the box method and gave him a short explanation of how I worked it out. However, I stopped short of giving the answer. And this was his response to me. In short, he doesn't really want the answer to this problem nearly as much as he wants to develop the skill level to be able to do problems of this degree of difficulty. I really do care about all my viewers and subscribers and try to help them as much as possible, but especially in this case where the problem in question is a natural extension to material I have already addressed, like I had done in Parts 1 and Part 2 videos. Plus, some of my best and most satisfying videos have come in response to questions such as Viva La Maria's. The thing that complicates this problem compared to the problems on my Part 1 video is that we need to find the correct combination of the factors of 18 and negative 35. And that raises our number of possible combinations considerably. Teachers have shown me different methods of factoring these more complex trinomials. There is a diamond method. One colleague showed me a method called bottoms up. At the time, these methods looked pretty good. However, I've easily forgotten these other methods and I just go back to using the box method. So here we go. Here's the box we'll use to factor this quadratic trinomial. We start by placing the x squared term, 18x squared, in the upper left cell of the box. And next we place our number term, minus 35, in the lower right cell of the box. Here's where the complexity starts picking up from my Part 1 video. Both 18, the coefficient of x squared, and negative 35 have multiple possibilities for factors. Numbers like 24, 36, and 48 have even more possible combinations. But starting with 18, the possibilities of factors are 1 and 18, 2 and 9, and also 3 and 6. And then we have the factors of negative 35, which are negative 1 and 35, negative 35 and 1, negative 5 and 7, and negative 7